Hello there. Uh, this is Al, and happy, not Christmas, happy December 27th. No longer Christmas. And so I guess this is the interval between Christmas and New Year's, where people are still either spending time with or avoiding their relatives in one way or the other. But perhaps one or two of you might be online with nothing to do, and so I'll try to provide some form of entertainment. In this case, the image here is that of Lindsay Lohan, the famed child actress and a child model turned actress turned cigarette smoking, what do you call it, advocate. She would be in cigarette commercials were such a thing still existing in the world. Well, to be honest, there are cigarette ads, but just not in what you would call the West. They have them here in Cambodia, where I am. Now, this not being directly connected with the ongoing discussion with the editor project, I was thinking that I would make another playlist, which would be, I guess, for a more in-depth look at some of the functions that I've been developing, not within the tutorials, because I would make them too long. So this would provide a place where I can give a link for more information about this or that function. The function that I was concerned with, I just noticed the other day. Let me just pause this for a second. Okay. Now, I don't know if you've seen the earlier episodes, I guess, of this series, but I have a function which I use to extract the type of a given object, and it doesn't use any dynamic types or anything like that. You can use it on any type, any class, or it doesn't have to be a class, and it will return you the type for that particular object. And the way it works is using this magic undecorate symbol name, which comes out of the DbgHelp library, DbgHelp.DLL library. And what that thing does is it takes symbols like this, oh, this wouldn't be very good. Now where am I? Dump bin symbol something, any obj. Okay. Internal error. I hit a Control C. I guess I considered that an error. Now these, know how to put this into a good format. Now the symbols, these symbols, are something that's actually in the program. Okay, this is like TsString. Now this program has done that. What the debug help thing does for us, which is to convert this. No, I don't need this anymore. To convert a string like what you just saw there, and turn that into a human readable string. Okay. Well, actually, I did want to keep up that older version. Now I noticed a problem with this function. See, originally it started out pretty simple. I don't think I need any of this either. It started out pretty simple. We could take a type. Now what's all this? Where am I? Oh, geez. That's all. I don't want this in here. Okay. I think I'm okay. I can check the differences in a minute. This is where I want it to be. So it takes a string like this and turns it into what you saw there, the full human readable the C code, whatever, that you would use to declare this. In this case, is a function, and I can run it here first. Make sure it's compiled still. So I'll print out this, and then I'll print out what that thing returns. TS undecorate here. Same thing. So it doesn't know anything about our program. It just knows the rules for converting all these question marks and ampersands or at symbols or whatever to into a real C++ name. Okay. So it says that what this line is telling us is that it's a public void this call. So that means it's a member of something, and it's a public member. Returning void. What it's a member of is list of TsString colon remove all. So this is a function that is a member of TS list of TsString, and its name is called remove all. And that's what this thing does. Now originally, the way you're a little bit on the history, if you don't remember, or if you didn't see it, I realized something using template that you could do with template, and which is this. If you take I don't want you to see what I'm going to do. Let's just move that away for a minute. If you take any old function, but make it a template function. Now I happen to have it returning a string, but let's just say void any old function. Which takes a const t-ref, it doesn't modify it. Right. Then it turns out that Microsoft has a thing called a built-in thing that will give you this string for the current function, and it's called funcDname. That's like a constant. So let's get rid of this for a minute. Suppose I print that out. Oh, well, just run this function. Any old function, and I'll pass it this here. Okay, no, it doesn't do anything with that t, but I'm passing it to it anyway. It should compile. Succeeded, and now give a warning because the parameter is under reference. So we won't reference it. Okay. Now this is going to print out the name of this function. The decorated name, the decorated name, right? Now if I run that same undecorated symbol name on this, then it's going to print it out in a undecorated format. Any old function, bracket, const star, and then taking character, const ref, etc. Right? Okay. Now what's so great about that? Well, what's great about that is, well, it's hard to tell with this font. Maybe I can change the font. That's better. These are angle brackets and these are round brackets. It's hard to tell before. What's inside the angle brackets, okay, happens to be the type of object I passed into that function, turns out. Okay? Because I passed it a constant pointer to a list of an array of pointers to constant characters. Let's run it again. Const star. Okay, that's like LPC stir. LPC stir, long pointer to constant character, string, and then a constant pointer to one of these is actually the way you would write that type down in C++ code. If I pass this this type of object, it's not going to do anything with the object, right? But it knows the type. In this case, it's what's in the angle brackets. It's class TsString. So within this function, all I got to do is extract what's in those angle brackets, and I can tell you what type this is. So I have a function that could that when you pass it an object, it will return. It could, in theory, return this value. That could be a string, or we could return a string. Okay. Now we could print it out here. And now I've got this any old function. Whoops. Using a bracket. It's true. I've got too many brackets. But actually, in general, I do want that. Because these funcs DName or whatever things those are not Unicode. Whoops. I'm so used to T cards. Okay. Now I'm going to get the same output, right? But instead, what I could do is don't just return that. Just take out what's within those brackets. So at first I had, okay, all right. What I'll do is now I've got this thing. It's undecorated. And what I would want to do is find the brackets and extract what's in the brackets. So I would say int in first bracket, just to be simple, or just I think I did this. This is the first test. Stir-toke bracket. Stir-toke it returns a string that I don't care about, but it modifies this string, removing everything up to and including this bracket. And then I would do that again with an end bracket. And that'll remove everything up to and including the end bracket, and return this string. Can't return this because this is. Oh wait a minute, I can't. Sorry. Because this thing returns, it modifies stir, but what it returns is everything from the beginning up to the bracket. So what I get if I run this function, if it'll ever compile, is just class, right? Oh, now I've got any old function. And next stir-toke to the end bracket. Oh yes. Now I've got any old function is included in there. Let's see why. Oh, that keeps running. Stir-toke should give me oh no, yeah, that's wrong. I want to do this first and then return this. Because like I said, this is returning all this stuff first, and then I want the inner part. Okay, so here you go. Just in 2 lines here, in fact, I don't even need this, right? I have an object, and I have and I have a function that prints out its type with no dynamic type, nothing. So that's what I had for a while, and then I realized, oh, that's great, yeah, but what about this? You know, now I'm going to get messed up with my count of brackets. You'll see, let's run up to here, right? Okay, now the first call, we got rid of everything up to here, right? And now if I do stir toke up to the bracket, I'm going to get almost the right answer, but I'm going to be missing a bracket. And worse than that, there could be more after this bracket. See, it's wrong because I've got brackets in the actual name of the type. So then I realized, okay, easy. Int m first brace equals, that's just called find, and then this takes a character value. And what I do is I find first of, and then find last of, and then return the middle part. That's one, I guess. And the total, the next argument is a count, so it'll be this difference. Last brace minus first brace, plus or minus 1. Usually the way I do this sort of thing is I run it first and I see how much off I am, and then I just fix it up. It's approximately that much. Whoops. Oh. Find first. Find last. Second. I don't know what I call those functions. I forgot. Should be find first, find last for a character. It's probably not. I could use a regular string. Come on. Hang on. Okay, I don't have such a function, but it works. I can use file and a string. Isn't that what I just had? What was it unhappy about in this case? I need to provide a. It's not unhappy. I was off. No, I shouldn't be off. This should work. List TsString, almost right. Oh, the last one, C, is in the wrong place. Yeah, that's right. Okay. Now, do you see what happened? Look at the undecorated name. Okay. Now, what I want to do is extract this string, right? And what I've got is, here's my function, here's the type being called to it, and then there's an open round bracket, and then there's more stuff. So the last occurrence of an actual closing bracket also goes beyond this point. So what I did was, okay, no problem. Almost done. We thought we were done, no, almost done. All we got to do is first take this string, whatever we got here, and just cut it off when we find an open brace. Now the last bracket, the last brace will be in the right spot. What have I done? Stir, toke. Okay. Now if you'll notice we were off by one. I'm going to add one, I think, here. No, minus, we had too many. Last time I saw 2 closes. Maybe, no. Well, we'll see. Either we're off by 1 or we're not. There. See? And just to prove that that's, not including it, it couldn't, but if you don't believe me, I'll put a little bar here to show you where the string ends. Oops. It's ending one more. Oh, that's right. But it's still good enough. Because it turns out that in C++, when you have a template thing and it includes, well, I'll show you the original again, includes 2 closing template, in a template thing, if there are 2 closing braces in a row, you have to have a space, or else it won't compile. So there's always an extra space when there's more than one closing angle bracket. But that doesn't matter. We can just trim the right. Now it'll be absolutely 100% correct. In fact, what I could do to show how correct it is, let's put quotes around it. Oh dear. Oh yeah. Wrong place. Any old func is the thing returning a string. Okay? So it's perfect. Absolutely 100% perfect, right? Well, I thought that was the answer. It's pretty much, the end of the story. That it couldn't possibly be. I mean, we're done. It's, we got the declaration, and the brace and so on, and everything's fine. But then I thought, well, what if there's something before this that had angle brackets, and I call this function. Like this function, somebody could add this maybe to a class that contains, it's a template class already or something. And so I just thought, well, I'm honest, it doesn't hurt anyway to advance up to the name of the function at least, right? Because I know that that's got to be in there. Right? There's going to be some declaration here, and there might be angle brackets here. If it turns out that this winds up somewhere else. I know I'm not putting it anywhere else, but somebody else could. And the function would stop working, and they would have no idea how to fix it. So I thought, well, that's easy enough. I know the name of the function. All I got to do is cut off everything up to the or search for this part, any old function, open bracket, right? And then we're fine. In fact, it should have a space. It certainly doesn't hurt. It's a better chance. So in fact, I could put a space, and I don't have a space in my current version. But so first things first. We'll deal with you later. Well, this part's okay. Int in cutoff something equals. Now what we do is we create a string. Let's see, it's func or something. And then instead of using func_dname, we use function. Right? And that'll give us any old function. And we can add a space in front. Okay. And then we should be able, and then add a bracket at the end. Right? Now, do we want that? Yeah. Find, see this func. Right? Now that's definitely got to return something positive. So what we'd like to do is take our string and go, mid, starting from this position, but of course now we've got this extra bit at the front, so we can just cut that off. Stir of mid down, cut head, number of elements, one's 2, one for the terminating null and one for that bracket. I don't have an end here. So we find if we start from take our string, start from the position where we found this string, and then cut that part off, but not including the open brace. Then we should be sitting at the first open brace, even if something bad happens to show up in front of our function. This is certainly working, but this is if there's an error to be had, now we've eliminated that possibility. From 1 to stir. Oh. This thing is I made it an array so that we don't have to take this string line. It'll just be hardwired into the program. We don't have to call a function. Well, we certainly wouldn't want to call any functions. Whoops, damn it. Let's say F7. For me, F7 is run up to. Okay, now here's our thing. Now, here's the thing. Any old function bracket. Now, you should definitely find that in stir. See? You can see it there, including the space. And I'm going to add a space to my current thing. If I now I'm going to cut off that many elements. And so now stir is right at the beginning, and the head's all gone, and in fact we don't even need to find first. It's from 0, right? So I could just say 1, I don't need this, and this is, well, first brace was 1, wasn't it? So this becomes -2. Because we know that the first element has to be angle bracket. So it's looking pretty good, with one small caveat. And that's the one I noticed yesterday. Or not yesterday. I've been noticing it and meaning to fix it for a while. It worked fine. Same as before. Okay. Now here's the problem. We're relying on this bracket. I know I'm assuming that any type that I pass into here can't have brackets. Like types don't have brackets, right? But that's not true. Types can have brackets. I mean, round brackets. So here is the one I want to make sure it works. Now I do have this type name defined. Type name is just like any old function. This has got to work. Now where's my function? Now here's my. I want the type name of my function. What's its type? Okay. Now its type is going to be a kind of a pointer to function type. So therefore it's going to have round brackets in it. So therefore the cutting off of the round bracket is not good. Now let me just fix this thing. That space helps to ensure that we're okay. Now I use function here in case somebody decides to change the name of this function. It shouldn't be dependent on its own name. Now all of this is doing that stuff. But in order to do it properly, well, I could do. Well, I don't have the round bracket thing, right? So what I did was at this point I have to have a function that'll do the thing that counts braces, counts up and counts down and stops, rather than relying on the round bracket. And I called that function Unbrace. And I gave a long description about it here before I wrote the function. Now, there are other reasons why I might want to use this function, so I gave it more functionality than it needs for this particular case. It could be useful for tokenizing an algebraic expression, for example, and getting rid of brackets. So what I decided is if the string doesn't start with a bracket, whatever you pass in the kinds of brackets you want. Here, by default, they're round brackets. If it does not start with an open brace, it returns the string preceding the open brace, just like stir_toke, and cuts that out of the string. If it does begin with an open brace, then the return value is the contents within the brace, and that part's cut out of the string, and continue on. Now, if there's no matching close brace found, that's an error condition. So it will return an empty string and wipe out everything else in the string. So that's how you can test to see if there was an error. If you don't get anything back, and you started with a string that wasn't empty, and you wound up with an empty string and an empty return, then that's an error. And it's very simple to implement. All you do, first assert that these are not 0. Now I search for an open brace. Now if there's no open brace, that's not an error. It just means there's no open brace. So the return value is the entire string, and I clear it out, just like stir-toke would. Now, if the next open brace is not 0, that means it's not the first character, then the return string will be everything up to the next open brace, and then I cut out that many characters and return the front, just like stir-toke. The final case is if there is an open brace. So now I'm just looping through character by character. Now, a comment here. Now, it's possible you could give the same for an open and for a close. The open brace and close brace could be the same. Now, I could rule that out, or I could accept it. I think it's better to accept it, because there's nothing wrong with taking something like this and saying I would like to take out the quoted bit, right? But the quote might have quotes inside. So if that's the case, you better make sure that you check for an open brace first before you check for a closed brace, because they might be the same. So 2 opens does not end the thing. Actually, I'm not so sure about that anymore. But then, what if there's only 2 of them? I scratch that. It's of critical importance to check close first. And it's too bad that's not going to work. Actually, maybe I should just rule it out. I'm going to rule it out. I have a function for unquoting. No, it's no difference. See, the idea, I thought that I could handle quotes within quotes, right? But if you have a quote, and then an open quote, and then a closed quote, and nothing else, then by checking the open first, it would never end, right? You'd have to check close first, but then that would fail in the case that you just saw. All right. Now, moving along quickly. All of this is a counter. So if I see an open, I increment the close counter. Otherwise, if I see a close, I decrement the counter. When the counter hits 0, I extract the midsection between those 2 braces, cut off from the head everything up to my current index plus 1 more, because 2 characters were removed. This is a one-off thing. I didn't figure this one out either. I just did trial and error. Return that return thing, and if that never happens, that means we wound up with not finding a matching close. Clear out the string and return empty, exactly as described. So here I give an example how it might be useful for parsing a string that has some algebra or something in it. but that's not the case here. In this case, all I want to do here, after cutting off the head section, is just do unbrace from where my current position is, which will be on top of a bracket. Now I could just return this, but I want you to see the return value. I'm going to compile it. I'll pause this for a second. Okay, finished compiling. Now remember, what we're passing to our TypeName function is a thing, which is a function in itself. So its type is going to be, we would like this thing to print out the type of this object called myfunc. I'm going to run up to here. First, let's see what we get from undecorate symbol name. It's quite long. Let's see now. Okay, there it is, all of it. So first, it's a returning class TsString, cdecl, TsStl TypeName. Now see, that's where using function is important, right? This is how the name of this did get modified. I modified it accidentally by putting it in a namespace. But function knows about that, and it will include this. So C, TC header includes the namespace. Alright? So we're okay, we're good with that. Now, it's all in one line, but I can go F8. First, it's going to find that substring, we hope. 22, it says. The top thing here tells you the return value of the last function. Now we're doing a mid. And what the mid did was it returned all of this. And that's, oh yeah, okay. So that got rid of the header section, the return value of this function. And the next thing we're trying to do is cut off this bit. So the next call will be cut head. And that returned this. So now we're at the angle bracket, just as I said. And now we should be calling Unbrace, which will do a count, pluses and minuses. And now you see there are round brackets in here. The round bracket method would have failed on this one. And now we return from the function. Print it out. So myfunc, this object, without using any dynamic this or that, has been determined to be class TsList of TsString. So it's a cdecl car start. So it's a, now it doesn't say, well, it's a function definitely, but it doesn't put a star. I don't know why. But it's a function, right? There's no name here. There's no myfunc written anywhere. It's a cdecl function that takes a pointer to character and a class reg. cdecl, pointer to character and reg. And its return value is a list of string. Okay? So just thought I'd just this is something that's going in the new list, and I'll put a link to it in the video where I initially discussed obtaining type names without using dynamic cast or without using the compiler setting dynamic type information. You don't need it. Okay, see you.